All right, thank you very much. Hello, everyone. Yeah, it's good to see such a great turnout. You know, last week I held a summit called Humans to the Sun and Venus. No one showed up. Thank you, whoever laughed first. I appreciate that. All right, so I'm going to introduce our wonderful panelists here. When I was asked by JR to lead this panel, I thought this is amazing because you don't hear about this particular topic very often when you hear about humans going to having a permanent presence on the moon or Mars. So sitting beside me is Ernest Sanchez, who manages the cargo mission contract at Leidos. Did I pronounce that correctly?
Leidos.
Leidos. Yes. Which supports both the International Space Station and Artemis logistics operations with over 25 years of end-to-end space logistics experience, started when he was 3 years old. His team, y'all didn't catch that joke? He looks like he's younger than 30. His teams have overseen more than 15,000 shipments and delivered over 380,000 pounds of cargo to orbit, from Earth to orbit, cargo to orbit, from Earth to orbit to the moon. Ernest handles the unglamorous but essential challenge, getting the right stuff to the right place every time.
Unglamorous, oh man.
Hey, you gotta make it, you gotta get there. Seamus Tuohy, who has a last name that is very similar to mine. Does not sound how it looks. Seamus oversees robotic and operational systems for space missions at MDA, the Canadian company known for building the robotic arms aboard the Space Shuttle and International Space Station. A specialist in robotic autonomy and systems integration, Seamus is helping engineer the backbone of surface logistics and infrastructure for the moon and Mars. If it moves cargo in space and isn't human, he probably helped design it. Wow. All right, and next we have Jacki Cortese, the Senior Director of Civil Space at Blue Origin, where she helps shape the next generation of human and robotic space transportation. With a background spanning aerospace engineering, government affairs, and program development, she bridges public and private sectors to support NASA's lunar ambitions and beyond. Her work supports Blue Origin's visions of millions of people living and working in space. I would argue that we are already living and working in space.
Not millions.
All 8 billion, how many are we? 8 billion of us.
Oh, that's a really good point.
Yeah.
We're all on Spaceship Earth right now.
That's right. And you know what's crazy? Spaceship Earth is weightless, even though we have weight as we stand on it.
What a deep realization.
Right? Yeah.
We need to change the whole tagline. We got to change everything about Blue Origin now.
There you go.
The vision has changed.
My consulting fee is not as high as you would imagine. All right. And finally, Tim Bulk. And so those of you who are into cosmology, in the green room, I just introduced him to the bulk and brain model in cosmology. Look it up. But anyway, he's the Chief Technical Officer for Special Aerospace Services. He's the co-founder and the Chief Technical Officer, a leader in systems engineering, manufacturing, and mission-critical aerospace solutions. Formerly with NASA, Tim helped shape the Commercial Crew and Cargo program and worked on missions to the Moon, Mars, and Pluto, a minor planet. Today, he's also president of SAS International and the visionary behind Who Dreams Wins, a foundation using aerospace to drive global STEM education. So what's going to happen is each of our panelists will have a brief presentation, and then we will go into a discussion about logistics of humans in going to the moon and Mars. So let us begin, sir. We start with you.
Okay. I wanted to start off by saying, I just want to give a high-level overview of what Leidos is and how we support logistics today on the ISS side as well as the Artemis side. And just to make a minor correction here, you know, I'm 33 years in the space business for logistics, but 25 years if I look at the next page here, so there's 25 years of end-to-end logistics experience within the Leidos company. You know, as Hakeem said, We're currently the prime logistics contract for the ISIS program. What that means is we are responsible for all the receiving, integration, packing, planning, and shipment of all the cargo to all the launch vehicles throughout the year. We're supporting probably around 14 to 15 flights a year, as well as the return aspect of it. So literally, 35, 40,000 pounds of cargo that our team is touching and shipping to the launch sites. We're probably integrating probably 98% of the pressurized cargo that goes on the vehicles itself. We have, like was mentioned, we supported over 175 missions to the ISS, well over 100 return missions as well, and almost 400,000 pounds of cargo, and that corresponds to about 15,000 shipments. And so one other thing I wanted to mention also is the Antarctic support contract is also managed by Leidos, and that is another big logistics contract where you're supporting in a very harsh environment, logistics, maintenance, operations, science, studies, and those things. So that is another great relevance there to Moon to Mars. We're also supporting the Lunar Outpost team and their LTV vision, and that is just a fantastic operations there. Our team under the cargo mission contract also is very involved with hardware certification efforts, from complex items like potable water dispensers to food warmers to crew quarters. Our Dynetics team supports docking systems, air constituent monitors. So we do a lot of hardware development and design for all vehicles, all environments today. So that is very, very relevant to what we're doing. And then the other thing I wanted to just mention is, as part of our Leidos, we're almost 50,000 employees, and we're supporting DOE and DOD in hazardous waste remediation and recycling. And so those are other areas. So these areas I have on this chart here are areas that we're going to leverage to put together, packages. We were recently awarded some BAA Moon to Mars white papers that we're being putting together. So we've got some very talented people that are all putting together solutions and ideas for the program. So all that put together, we kind of bucketed our services into four main categories: our logistics, where we're doing all of our cargo services; our engineering, where we're doing all the design and development of various harbor products. One thing I didn't mention, but we also today are outfitting the crew for all their clothing, consumables, and so a lot of the usage rates are absolutely applicable to lunar and Mars habitation. All the operations and mission operational support that we give as well as part of that. One thing I wanted to mention is some challenges and lessons learned. So there's many challenges in logistics, but some of the ones that we're really focused on is having an integrated logistics system to support all the tracking of all the property and all the consumables that are needed to be tracked for lunar and moon operations. Life cycle planning, interoperability is very critical. Obviously, common components, common sparing, common standards help create efficiencies. Even our cargo bags today, they're very standard sizes and shapes. And so as we move into the future, you're going to have different size vehicles, different interfaces. And so it's important that we communicate often on interfaces to try to maximize interoperability and interchangeability, those kind of things. As far as lessons learned, you saw Vanessa was up here and she talked about leveraging the space station, all the lessons learned there that were accomplished over the years. And we are on the Leidos side are trying to harness that and in our area of expertise with the cargo logistics and packing integration, we've been very innovative with our tools. One of the challenges we've seen on the ISS side is vehicle cadence. Things don't always go as planned. The flights have issues. There's weather delays, and so you're having to move cargo from bag to bag. Things happen on orbit where you have failures that you have to address. So one of the things that we've really shaped over the years is just creating very agile tools to enable us to rapidly move cargo and manifest from bag to bag or vehicle to vehicle to make it very cost effective. The other thing that's very important, I think, is automation of our consumable tracking. Today it's very manual, labor intensive on tracking consumables, even hardware for that perspective. And so right now we're engaging different technologies to try to make that more efficient going forward, more automated to take crew time and ground time out of the equation. And that is all I had.
What did you say, go next?
Wonderful. And next we have I guess until I announce you, Seamus Tuohy.
And like magic, it pops up.
There we go. There we
Let's
go.
see. So I'm with MDA Space, is the largest Canadian space prime, and very large company. We also have offices in the U.S. and the United Kingdom. And we've done a lot of work in space over our history through various different acquisitions and names, but we're back to being MDA Space. That we have over 450 space missions that run the gamut from, we develop constellations for broadband and direct-to-device systems. We develop geointelligence product based on our own Earth observation satellites that we built for the Canadian government. And where I am is in the robotics space operations, probably most famous for, we did the arms for shuttle, we did the arm, the Canada arm for station, and we're currently under contract to build the Canadarm3 for Gateway. So we talk about logistics. It's something that is going to start small, obviously, but then grow. But the key here is trying to design it in at the beginning. Try not to backfit it later on, because what you'll find are things don't work together, or you have to go replace things early on. So for the Moon and Mars, we think there's an opportunity here to actually start fresh and to show how the current systems that are in development can be carried forward with new systems that integrated into an end-to-end supply chain. You know, the big challenge is to evolve from having a bunch of tools that people talk about having, you know, we're MDA Space, so it's robotic arms for us and surface mobility, but landers and cargo pallets and packages, and how all those fit together. You know, go from having these individual items to having an integrated flow of how something goes, you know, from an Earth production facility to a loading dock to a launch vehicle to the surface of the Moon to where it's supposed to be used, to a depot, you know, and eventually be thrown away or reused in some manner. You know, and when we move from, you know, Earth operation, Earth orbit to Moon, you know, that it costs us a little time there, communication lag, but then going to Mars is going to be ridiculous. And so going from, you know, right now we have human in the loop systems. We have to start developing things which are human on the loop, and also fully autonomous systems that either have to have enough smarts to act on their own or enough smarts to act with a human, which is even a higher level of smarts, I think. The other thing we have to worry about is going from, you know, missions, you know, individual missions to doing sustainable presence. You know, having something which is always there and always available. Since I'm from MDA, I have to talk arms. So we're taking the C3, Canadarm3 arm that we're developing for the Canadian Space Agency on Gateway, and commercializing that to a brand of arms called Skymaker that can run the gamut from small to large, from things that lasted a lunar day to last years on the surface of the Moon in an orbit in space around the Moon. On the lower right, we're also on the Lunar Outpost team. That's why I clapped when you mentioned that, which we're very happy to be that. And so the Skymaker arm can go from in-space applications, Earth orbit to lunar orbit, down to the surface of the Moon. We also do surface mobility. It's not something we're as famous for. None of our rovers are on the Canadian $5 bill like the Canadarm is. But we've done a lot of it, but it's been component level, chassis, mobility systems, sensors, things like that. So what we're doing right now is looking at how to apply that experience we have in operating arms and developing robotic systems and rover parts to actually looking at complete rover systems, but really thinking in the large about how they all fit together into a logistics system. We did a demonstration last December for the Canadian Space Agency and looking at autonomous roving, but also how systems actually get off a lander onto a rover, and then systems get delivered to, in this case, a pressurized HAB module, and looking at how this would be a shirt sleeve transfer of goods in a pressurized container. And when you start looking at that, we think of operations as being a dominant thing in your design, that a lot of people tend to want to fix operations after they build something. We tend to want to build operations into it. It really teaches you a lot about how you should design your systems. I'll hand over to Jacki.
Thank you. And next we have Jacki Cortese.
Okay. Hi, everybody. Can you guys hear me okay? Okay, sweet. Thanks. Hi, I'm Jacki Cortese, Senior Director of Civil Space at Blue Origin. Thank you for having me. And I will say I'm embarrassed because I already now need to change my first chart, thanks to our dear moderator, for saying it's really millions of people living and working off Earth versus in space, where we're all millions of people living and working. But you know what? We won't go into the complexities of that right now. So the vision of Blue Origin, I think, is very clear, which is we want to get you all where you need to go. So once we're on, Mars, Moon, wherever we want to go, we want to help get you there. And so we're focused on developing the commercial transportation capabilities to get us all over the solar system. And a really cool thing I think maybe some people don't realize about Blue Origin is, specific to Moon and Mars, every single business unit, every single product that we're making at Blue Origin has applicability to supporting both increased activity in the Moon, Mars, lunar vicinity, and general deep space. And I'll just give you some quick examples. So our New Shepard suborbital vehicle, which is probably our most public, widely known vehicle, actually just recently conducted a lunar gravity simulation flight, completely full to the brim of payloads, where we spun the New Shepard capsule to simulate lunar gravity. And it was an amazing success. It was very cool. And so, you can do the same thing on New Shepard for Mars gravity, for example. So I think just that example in and of itself, a lot of the rest of what I'm going to talk about is a lot more obvious. But just the fact that a researcher can literally buy a payload, fly on New Shepard, and simulate 3 amazing minutes of lunar gravity for a fraction of the cost of actually going to the Moon means we're in this amazing, brilliant commercial space revolution, and the US is undeniably the leader of that. So just wanted to start with that example because I think, like I said, the rest is a lot more direct to the Moon and Mars, but that's just an example that I'd like to highlight. So at Blue Origin, I think, a lot of our big vehicles that are really widely known are for the Moon. So I'm going to hit on those first, but there is major applicability of all of what we're doing at the Moon to Mars directly. Hopefully, first and foremost, I'll hit on, I hope everyone in January watched the successful first flight of New Glenn. New Glenn is our heavy lift rocket at Blue Origin. It really enables everything that you're going to see on the rest of the screens, but because you are all tuning in, I'm not going to spend time on it right now. I'm just going to assume that everyone saw that. So we're really excited to be flying again here soon with New Glenn. And I think one interesting thing about this chart that I want to highlight is a couple things. So our Blue Moon Mark 1 uncrewed lunar lander is a key part of our entire logistics architecture. It's a 3,000 kilogram class, single launch, no refueling lander, and it's flying to the Moon this year, 2025. So stay tuned for that. We're really excited about that. And that's a key part in our vision to sustainable lunar exploration and unlocking infrastructure class access to the lunar surface on a repeatable basis. So that's a big thing to look out for this year. I wanted to show you guys a real picture of the lander. Obviously this is a render, but comms has some big stuff planned and they rejected me. So you're gonna have to deal with this picture for now. So stay tuned for Mark 1. And I will say a cool thing about Mark 1 also is that, and I'll get into this more, we've set this all up from the beginning to be production class vehicles. So we don't intend to build just one of any of the things that I'm talking about. So again, Blue Moon Mark 1 headed to the Moon this year, a fully Blue Origin funded demonstration of that capability. We're so excited. And the reason that we fully self-funded that demonstration was because we are a provider for NASA for the Human Landing System program. So the vehicle you see on the far side is our crewed lunar lander for Artemis. We're really excited. We're going to be flying that in an uncrewed demo and a crewed demo this decade. So that's obviously in that picture for people to step out access onto the lunar surface. But what's not pictured is also a cargo version of the exact same lander that can fly 20 to 30 metric tons. So again, when we're talking about setting up a long-term infrastructure on the lunar surface, on Mars, these capabilities are truly from the beginning designed to enable these big infrastructure class missions to occur. So like I mentioned, just to hit on it quickly again, sorry to render. You'll have to trust me. There's a lander, I promise you. So again, 3 metric tons flying this year. And I will say one thing that I'll hit on as well toward my infrastructure class production line point is our second Mark 1 is simultaneously in assembly. So as we all know, landing on the moon is a big challenge, especially with us having all hydrogen. So it will be the largest and first hydrogen lander if we're successful. We want to have another one ready to go so we can keep iterating in the event that we don't achieve all of our mission objectives. So that's another key part of what we're doing, is to be ready to go again, trying to be hardware rich as possible. So Mark 1 is a key enabler of our vision of logistics on the lunar surface and unlocking all these amazing things that all these gentlemen want to do. So that's key for us. Another key part of our architecture that is applicable to both the moon and Mars and is a little less known, so I'm trying to hit on some of those things, is our transporter vehicle, which essentially provides the cryo-cooled propellants from LEO to the lunar vicinity, but it doesn't have to stop there. So transporter is being developed for the Human Landing System program, but again, with our vision on production level vehicles, we plan to make a lot of transporters, and the beauty of a cryo-cooling, zero boil-off stage like this is it can do lots of things. It can deliver 100 metric tons to the cislunar vicinity. It can deliver 30 plus metric tons to Mars. It can do so much at NEOs. It's a very cool vehicle, and we're making huge progress on solving kind of one of the holy grails, which is that zero boil-off, sustained cooling and storage of hydrogen and oxygen, which is core to our vision at Blue Origin. So just hitting on transporter because a lot of people don't know about it. And then lastly, I did have to show you guys some hardware since I got rejected at the other turns. So just so you know, the heart of our entire lunar and Mars architecture that I've talked about in this presentation. So please tune in tomorrow because Dave, our CEO, is coming and he's gonna share a lot more than I shared. Again, I'm being restricted, I'm being held back, but that's okay. Dave will share a lot more with you guys tomorrow. But the core of the architecture that I just discussed that Blue Origin is working on is the BE7 LOX hydrogen engine. Again, a core commitment at the company to hydrogen and mastering kind of that holy grail propellant mix for the future resource utilization. So here's just some great successes. We presently have BE7 hardware on 4 different test stands simultaneously. So again, really trying hardware-rich production class mindset so we can have, predictable, reliable, and affordable access to the moon, Mars, and the deep space exploration environment. So that's all I have. Thank you.
Thank you. Now to Tim Bulk.
All right. I'm still wrapping my brain around bulk membrane versus bulk modulus, which I used to get teased about in college. So,
Totally different scale. Yeah.
Okay, so who is SAS? We are somewhat the stealth-like company that helps companies like Blue Origin and others like ULA in making their systems safer and more reliable. Just a quick story. When I left NASA in 2007, my third contract with the company was with a small company called Blue Origin, which was 45 people. And they wanted to understand how to put a propulsion test stand in the middle of Kent, Washington, in the downtown area. So just a little history on what sort of the things we started doing. Sure. So we are a new aerospace and defense technology company founded in 2007. Last April, we transitioned the company to majority ownership to Godspeed Capital. So I've sort of come full circle in the whole startup to transition phase. We are located in Boulder, Colorado, with a manufacturing facility in Arvada, Colorado, which is about 30,000 square feet, where we make hardware for companies like Blue Origin and ULA and others. Last year, Godspeed also acquired 3 other companies, Quintron, which makes secure communications, located in Santa Maria, California. Also, Willbrook Solutions and Concordia Technologies, which was heavily in the missile defense side of the business. So when the company was transitioned, we were about 155 people. Now we're about 300 people and growing with other acquisitions coming this year. So we are a trusted provider of high-value, mission-critical solutions and hardware as well as services. We are not truly a CETA contractor to the government. The whole idea was to be small teams doing great deeds for the primes and the developers, because my background, I came from a hardware development background and from industry prior to going to NASA, and worked successfully on the Atlas III and Atlas V programs. Currently, the company has embraced a full life cycle model to help our clients. Strategic services, program and mission planning, then engineering services, technology development, and specialty products. As we grow, we want to be making our own systems as well. From the strategic services side, helping companies win new space work throughout the 17 years. We've helped companies win over $10 billion of new space contracts. And so again, when we do that, hopefully we're providing engineering services to make them a safe system and a successful system. Growing, we serve the needs of NASA, the DoD, the intelligence community, missile defense, and as well as I mentioned, the civil space companies and other space customers. I'm not going to read all this of what we've done. I'll just highlight some of the stories. People, at least NASA and others in the industry, know us through spaceflight safety. That's a trademark process and system we apply to our clients. We've applied that over 7 years, helping Blue Origin with New Shepard. Yes, I had to brief the founder prior to the first human flight on how his team did in qualifying the hardware. And of course, that flight was successful and a high point for SAS to make that happen. We were also involved, of course, with the Antares Cygnus program, delivering cargo to the ISS. That was part of the COTS program, and then the Cargo Resupply Services contract with NASA. Our breadth of technical capability now within the company spans from the logistics work all the way to mission planning, special operations, and of course, secure communications, hypersonics work, and briefly our international business work, where we help other companies allied to the U.S. wanting to start operations here in the U.S., selling either services or products within the U.S. We had a big win this year with our STEP-R Lunar Logistics BAA win from NASA. We were one of the few companies that won all 7 critical areas, or 7 critical CLINs for that BAA. We focused on a system of systems approach, which applying some software AI tool sets that we took from aviation and special operations and applied it to NASA requirements, and really applied a system engineering solution as well as the tool set, and then some innovations with robotic carriers and humanoid robotics as part of the study. So that just kicked off 2 weeks ago, and it's going to be a very fascinating BAA and study. Our team included SpaceWorks. Of course, being in Colorado, we had to leverage Colorado School of Mines, Astrobotic for cargo carriers and how they're going to apply their next generation systems. Of course, we're also open to working with others such as Blue Origin and the suite of other companies that are going to be providing cargo directly to the lunar surface. And then uniquely, we pulled in a commercial company called Agility Robotics with their Digit humanoid robot. If you haven't seen the videos of what that humanoid robot is doing in warehouses, we're going to be working with them on how that can be applied to the lunar surface. And it just goes to the point that Vanessa talked about how astronauts and robots are going to be working hand in hand in the future. So that's all I have.
Excellent.
Open for questions.
Excellent. You know, Tim, you put Santa Maria up there, man, and triggered me. last August, I went and took a 30 cycles on the zero gravity plane. I made it through the first 10 and discovered why it's called the vomit comet. Don't mention that again. All right. So what we're talking about here, establishing this infrastructure and supporting it, is going to be easily one of the most complex endeavors in human history, right? And I think we really take this a little too casually anyway, because I still think of the fact that we have evolved from Homo habilis, to whom breaking a rock and creating a sharp edge was an innovation, and now we're dominating space. So I have questions for you all in various topics. So let's talk about end-to-end logistics complexity. So, Ernest, to you first, sir. What logistical challenges from low Earth orbit do not scale well to the moon and Mars?
Well, I think I touched on it. Can you hear me? I think I touched on it a little bit earlier. I think one of the big challenges for the ISS program today is just not really challenges, but we have the luxury of working several flights in parallel, and just being able to make changes rapidly and be able to to change cargo, to change vehicles, and I think we're packing or changing manifest up to right at launch, at launch minus 24 hours in some cases, so very late in the flow. And I think I think there's going to be less flight cadence, going forward for Moon and Mars missions, at least getting started. I think so that's going to be a little bit more of a challenge. So I think the manifest of the cargo and consumables and making sure you have the right sparing identified and interoperability, I think all those are going to become even more and more critical going forward. So I think that's something that we really got to focus on.
Yeah, do you anticipate that the mass will be massively increased per mission?
My understanding is very mass constrained, and so that's another area where we have to just come up with innovative ideas and solutions to reduce in mass, maybe having repurposing items, having different purposes for stowage materials, just get innovative with the way we pack. Today we've done a really good job with our stowage and packing solutions and coming up with innovative ideas, but there's always something else we can learn. Things that also with regards to consumables, ISS has done a really good job of leveraging like pantry style functionality, and so I think we can leverage that a lot more and more like ground laboratories and do more of that to kind of save on mass. But mass is absolutely critical. Anything that we build or design is always very mass limited, mass constrained down to the ounce. So we're got that in.
Wow.
Yeah.
All right, let's turn to Seamus. Interoperability and transferability. So what does interoperability mean when you're dealing with multinational payloads, carriers, and habitats on another world?
So I think when people imagine interoperability, they try to concentrate on the physical connections. As the docking mechanisms work, the plug, same volts DC, stuff like that. That's not the way we think. We think of the operability part, is how it fits together operationally. Because that's the thing that it really takes a lot of the time and cost. If you don't figure out how things can operate together, when's the handoff? Who's in control? Who's responsible for things? And as you design these logistics systems, you're trying to design them end to end to be optimal. But what that also means is that different elements may be suboptimal. If you look at like the shipping industry on Earth, the container size, was not driven because it was the optimal container size. It was driven because the width and the height were limited by the U.S. interstate system. So that was a constraint that was put on. And when people thought about how to put goods rapidly through a system, it turned out that was the easiest thing to do, to make it so it moved quickly through intermodal changes, it moved quickly through the interstate system. And I think the same thing for the Earth going to Moon and going to Mars is how can things go easily through the system? How can we create standards? How can we utilize things and operate together? Not so much that each element is optimized, but the whole total end-to-end system is optimized. And also it means making decisions about existing systems that you just have to live with, and not having to go back and change something that was designed 20 years ago. But how to utilize that in a efficient end-to-end system.
Mm-hmm. Wonderful, thank you so much. Turning to Jacki. So Blue Origin aims to be a transport backbone. Explain that to us, generically.
Yeah, sure. I think definitely to kind of tie together everything I was mentioning earlier, we want to be a foundational go-to provider of flights for people, right? We fly people all the time on New Shepard. We're going to fly people on our Mark II crewed lunar lander, and infrastructure class cargo to pretty much anywhere in the solar system. That's the objective. And so there are some things that you see woven through, like I said, a lot of what we're doing. You see, a long-term commitment to, like I said, the LOX hydrogen vision. And that's a key part of it. We've been working on it, like Tim said, since the very beginning, in perfecting it and really trying to master it. So that's one, kind of core tenet of what we're doing. It's a core belief system of the company because, again, at the end of the day, we think a key driver of why you explore space at all is in situ resource utilization, is, finding things there, is sending 1 million of your rovers around to dig it up and make it happen. So to do that, you want to take hydrogen from the beginning so you can explore through cryo cooling and other key things. You want to be able to say, okay, if there's water on the ice, which, water ice on the moon, which we now know there to be, we want to use that for propellant so we don't have to take so much from Earth. So some of those core tenets, again, the second big one is that producibility. We really want to set up from a production mindset from the beginning. So that's something that we spent a lot of the last couple years focusing on. We have some beautiful buildings in Florida and Huntsville, but the lovely thing about those beautiful buildings now is they're not just beautiful on the outside, they're full to the brim of hardware, and that's where we want to be. So that's another key part of us trying to have this objective of being the transportation backbone. And the third thing I would quickly say is we did start a nonprofit called Club for the Future. And a big reason for that is it's really awesome for all of us to build all these transportation systems. But if no one's going to use them into the future to do this glorious, sustainable, long-term exploration, then it was probably not really for anything. So we need, our partners, our colleagues, but also the next generation to be thinking, how am I going to leverage these capabilities that exist into some amazing business idea or some, inspirational journey, and what are we going to do? Because if we don't have that, then again, all of this was, not sustainable actually. So those are kind of the way that we are trying to frame ourselves to be this, go-to transportation backbone in various ways. So.
Wonderful. Thank you. And Tim, sir, your team just won NASA's STEP-R Lunar Logistics BAA. What does that win say about how NASA's thinking has shifted around logistics priorities?
Well, I think now it's starting as the previous presentation stated, is that now it's real engineering behind how are we going to really do this. And it's not just studying the problem, but really applying good system engineering practices and engineering to say, okay, how are we going to limit the astronauts' time on not doing maintenance and servicing of the hardware, but actually doing science? And so balancing that whole aspect of lessons learned we've learned on ISS to now working with a robotic, humanoid robot possibly, or other type systems that allow the astronauts to really do science and do experiments versus continuous maintenance on the systems and survival.
When you talk about this doing science, it reminds me of a lot of our sci-fi movies where they typically have this science mission, but the corporation has inserted their guy who's really there to get those valuable metals that Jim told us are sprinkled all over the moon, right? So just watch out for that. All right. So to the panel, if you could design one piece of infrastructure that doesn't yet exist, and I know it's not a space elevator, but would radically simplify Moon-Mars logistics, what would it be? Anybody, but all of you have an opportunity to answer. That does not yet exist. One piece of infrastructure.
So when you think about logistics, the transit part, once it's on a platform going from point A to point B, is very complex and very hard, but it's engineering. You can figure out. The fun part really comes in on the intermodal parts. How it goes from one platform to another. And so if you ask me about the infrastructure elements that I would love to see exist that don't quite exist right now, is how do things actually go from your lander onto a rover? How do things actually go from a rover into a pressurized hab or into a depot? And so you're talking about robotic systems, cranes, things like that. I mean, to your point, I don't think we want astronauts lugging around suitcases. They have more valuable things to do.
But they're weightless.
Well, not weightless.
They're less weighty.
Yes, less weighty. But it's that intermodal part. So it's those systems, those whether it's robotic systems or human-operated systems that cause you to be able to transition payloads from one platform to another. That's what I'd like to see. That to me is where the interesting thing is.
Interesting. Any other inputs?
Well, in my experience, everyone thinks that the rocket is always the hardest part. And it's really not. It's the concrete and steel that ends up usually holding up a launch or the overall program. And I think on the moon, how are we actually going to build things? And how are we going to do the simple things that we take for granted that, someone else is going to have that inflatable habitat module. But there's more to it than that. So I think that's, maybe that's another company that I'm thinking about is, come up with someone that you can create concrete on the moon, for example.
Wow.
Something like that.
Particularly
with the regolith.
If you go to a building site, on Earth, you look at all the specialized equipment.
Right.
They have things. They have like a specialized system that just loads sheetrock.
Right.
And is that a vision for the moon where in order to build a structure on the moon, you have to have 20 different machines? And so the idea of like how do you design things so that one machine can do what 20 do on Earth? It's how you actually construct things will be a good trick. Yeah, I like that idea. Yeah.
Well, one innovation we have here on Earth that I've seen at a lot of construction sites that could be very useful on the moon but wouldn't work is the fact that, in certain dry, dusty places, they're constantly spraying it down with water, right, to keep the dust down. And I don't know how you could deal with that problem on the moon, given its issues. So let's play a little lightning round here. You ready?
Okay, I'm ready.
All right. Finish this sentence. The single biggest risk to successful moon and Mars logistics in the next decade is the politicians. No, I'm just kidding. No.
Yeah, budget.
Budget, yeah. The budget deciders.
Budget deciders. Biggest risk.
But we're just talking the next decade.
Next decade.
Yeah. Or a major risk.
I think just coming up with solutions to these hard problems. All this summit was incredible, and there's a lot of things that are happening, and I think it's we got to work together as a team. But there are a lot of challenges that go on, so it's really endless to the challenges we have. But to name one thing, I just can't do it.
You just did, man. You just stated education and training.
Yeah, it takes a village, and these folks in here and the folks on here on the stage are part of the team that's going to make it happen. We got to all communicate with each other. There are a lot of challenges out there, from the vehicles to the consumables to just how to do things, how to close these technology gaps that a gentleman talked about earlier today. We just got to get innovative, think outside the box, like Vanessa said. But there are a lot of challenges out there, so it's hard to just say one. There's just 1,000 challenges.
Yeah.
So, apologize for saying this because landing on the moon is risky. I think that's recognized. But the types of systems that Blue is developing and that SpaceX are developing, because you said 20 to 30 tons. So just imagine that for a little bit. That we're talking about CLPS landers now that we're, that are in themselves very difficult in succeeding on landing tens of kilogram payloads. And we have companies now developing things which are, 20 to 30 tons at a time. And just think of how that would change things, that if within the next 10 years that becomes routine, that's a steady thing you can depend on, that it's like, oh, the semi truck is pulling up with 20 to 30 tons of stuff to be delivered to the moon. Then all of a sudden, all the stuff on the surface of the moon becomes possible. Because if you can't get the mass to the moon, all the stuff we're dreaming about, all the stuff we're trying to plan just doesn't occur. So to me, that's by necessity the biggest risk is realizing the routine large landed mass capability that companies are developing. And I know that Blue will succeed in doing that. So.
Yeah. Yes, sir.
I'll just say the complexity of the ConOps. I think that there hasn't been a good reliability assessment on the ConOps that may be the biggest risk to.
Define ConOps.
From processing on the ground to launch to refueling in space, the complexity of refueling in space, to we've seen the challenges of just landing on the moon, and again, to the point, landing large masses on the moon. So that entire ConOps scenario is challenging. It's incredibly risky situation.
I would say not a risk, but an opportunity to adjudicate risks is, and I kind of said this earlier, we're living in this kind of amazing time where there's more, I'm just speaking, for US domestic capabilities, there's more capability than ever. A lot of it was self-funded, by the market or by, individuals or whatever. And I think the best thing is we need to maximize leverage of everything available right now to solve a lot of these problems. So, from suborbital to moon, Mars, beyond, there's these capabilities in industry and, in code development with NASA that are going to change everything. But we should be maximizing them to the greatest extent possible every single day. Like, I don't want any rocket to go not full, or any lander to go not full, or any suborbital mission to not be flying, because we could be doing so much now. We have to find ways, I think, to do as much as possible to maximize this golden age of, there's a million vehicles, right? There's OTVs, there's all these amazing things that exist now in this point in time. And I just think if we can find the best way to maximize them, to do tech demos, de-risk, do maybe smaller or different science, that would be a great thing we could do to de-risk a lot of the concerns.
Thank you. Yes, that, and I think there's some public perception issues that need to be addressed as well. All right, one last one. We have 7 minutes left. Let's play Interplanetary SimCity. If each of you were responsible for one core element of a permanent moon base, what would you own and why?
Power.
Power, because then you'd have power?
Yeah, that's right. Bulk power.
Well, I would imagine, do you think that it would be centralized or would it be distributed like solar?
I think it's probably going to be a mix.
Yeah.
I mean, we're going to have to demonstrate nuclear propulsion in space, do test demos on the moon. And so that's really where, personally, my passion is, where I'd like to see funding be put towards. I think there's some things coming out of the White House last week or the week before about nuclear propulsion or nuclear energy in general. So to me, I think that's an area I'd personally like to control.
Power. It's interesting because when I was at NASA headquarters, I was interested in, my graduate students and we developed a propulsion technology based on magnetic reconnection. But it turned out that the type of power that we would need does not exist, and for an in-space application. But continue. Yes. What would you own and why?
I'd say maybe like a carrier or lander. It'd be just kind of interesting to see how to outfit it robotically and all the cargo stowage, and I think that would be.
So would that be for the logistical
Yes,
landers?
yeah, logistical
Got-
landers, yes.
Wonderful, wonderful. Yeah. Why did you say why?
I'm sorry?
Why?
I just think it'd be a great challenge to overcome.
A man who loves a challenge.
That's right, that's right.
Love that. Yes.
So if he's going to own the charging station, I'll own the foodstuffs, the agriculture system.
There you go.
You know,
How do you envision
food
that?
stores. So with all this landed mass going, you're going to have a lot of volumes that are carrying consumptions. You know, things that are consumed and they're going to be empty. So you know, just like people nowadays are building homes out of containers. You know,
Yeah.
you can imagine a world in which those whatever we pick as the containers for stuff going on the moon are reused, or repurposed, and repurposing them as agriculture systems, agriculture facilities.
Yeah.
So we can start, because you can find water on the moon, you can find other things on the moon, you can find other things on Mars, stuff like that. But food, that's what I'd like to own.
All this transport, it just made me realize something that, you have to rocket things up to the moon, but you can just drop them back down to Earth. Thank you. Some people are like, this dude's an idiot. Jacki?
Well, so many good ones are already taken. I assume I can't repeat.
No, you can't repeat. You got to get your own.
Okay. Well, I'm going to
part of the
envision
moon.
in this
Yeah.
future Sim City. 'Cause,
Yeah.
what's Sims without people? Sims are people, aren't they? The Sim itself is a people. Yeah. So I'm going to assume there's lots of people. So I'm going to say this is not on behalf of Blue Origin. I want to own like the Walmarts. I'm trying, because if there's people somewhere, you got to have all the things that people need. So I'm trying to like land a Walmart or something.
Well, wouldn't it be like robotic delivery to your front door?
Yeah, exactly.
Yeah.
See, right?
Yeah.
It's like, need my CVS,
You could end up being the
everything I
richest
need.
person on the moon.
That's what we're going for now.
That's what we're going for. Wow. We have 3 minutes left. So, any last words, or the thing I mentioned about the public perception? Like, one thing I get about space activity is that we could be solving problems here on Earth. What is your answer to those sort of sentiments? Because this, we in the room appreciate the big picture of where humanity is going, what's good for our national interests, because we're deep, we're involved, we're intimate with it, right? But I think the average person who doesn't have that experience can easily, just like when I watch a science television show, we tell the results, but we don't tell how we got them. I completely understand how people could say, crap, that's not real, right? But why the value of what we're doing? Very quickly.
I think if I go back to my NASA days of how many dollars spent, but looking historically from what happened through the Apollo era, and then the genesis of semiconductor technology and the revolution in computers were spawned by that investment. Look at it just in my personal experience with the NASA COTS program, where it was taxpayer $500 million that, quite frankly, developed 2 new launch systems and multiple launch pads, but then changed the way we access space now.
Wow.
And so
That actually sounds kind of cheap.
right,
Yeah.
which people say, where does Starlink come from? Well, Starlink would not have happened if NASA didn't kick in the $500 or $300 million and have a CRS contract.
Right.
So just some points there.
So I would say there are very few problems that are so unique that they only have application in one area. So if you talk about sending a crew to Mars, you're going to need to do remote medicine. Well, there's a huge need for that on Earth.
Yeah.
And so just like a lot of things came out of Apollo, a lot of things have come out of Shuttle, a lot of things come out of the space program that have benefited life on Earth. That used to be one of the taglines, for the station was, it's about life on Earth. That the way I would try to sell it is to say the investments here will pay back in raising the quality of life of people on Earth and solving problems that we have here. Whether it's like I talked about agriculture, being able to grow things more efficiently would be a good thing to do on Earth.
Yeah. For the record, I got chickens in my backyard. I don't know about anyone else. And I've had 3 harvests of my mustard greens already this season. Yeah, I just did this for the first time this year. So, any other thoughts?
I agree 100%. I think the advancements in technology and medicine for the better of humanity is really what it's all about, and that's what we need to communicate and educate to the folks out there.
I'll give you the last word, Jacki.
Oh, I agree with what everyone said, and for the sake of not copying too much, I guess I would say I think just the inspiration and the new ideas that are going to come from all of this. Like one cool thing about New Shepard is just in flying more people to space that traditionally and historically would have never had the opportunity to go.
Right.
A big part of what we've been doing on New Shepard is, unintentionally, is there's been a push of many people who have been the first person from their country to ever go to space.
Wow.
First of nation passengers and astronauts. And that in and of itself and that inspiration, I think, is just so huge. And again, coming up with the next idea, which is the next internet, the next whatever, it's going to be. So I think that excitement and the curiosity and stoking that through space is absolutely a worthwhile investment from every corner.
Yes,
So.
yes. I would like to thank all of you. You guys are brilliant and love the work that you've done. Let's thank our panelists. And with that, our panel has concluded.